G'day folks, this is Ed here from Ed Systems. A few of you inquired just how you would start a refrigeration compressor and what's required to start one. And I'm just going to run you through the basics of how they work and what's required to start a compressor. There are many different types. Some of them are a low start torque compressor, which does not use a capacitor. Some of them are a high starting torque compressor, which does require a start capacitor. And some of them use a start and a run capacitor, like this commercial one here. And again, if you do not have this starting gear, you will not be able to run your compressor. These are your starting capacitors. They're typically fairly high microfarad. This is 125 microfarad, 260 volt or 330 volt. These are run capacitors, typically low capacitance. In this case it's 15 microfarad, 420 or 470 volt. Run capacitors typically operate or are rated for twice the line voltage that's going into them. This is a type of starting device from one of these compressors. It utilises a start and run capacitor, and it's just a simple relay that momentarily starts the compressor and then sets it into run mode once it's started. This is a little starting device for a high start torque compressor without a run capacitor. You have your capacitor hooked up to this terminal here and number 13 here. You connect your common or neutral lead here and your active lead here. As you can see on this one, the bottom centre pin is your common or neutral. The top left pin is your run winding, so that's your positive or active lead of your AC lead, and this is your start winding on the right. Start windings are only momentarily connected by the starting relay, which is what's inside this copper coil here, and they are disconnected once the compressor is running. If you continue to run a compressor on its start winding, you will burn it out. If you try and run a compressor without a run capacitor or the wrong kind of run capacitor, you'll probably burn it out or destroy the capacitor. This is a low starting torque starting device. It uses a thermistor or resistor or something like that instead of a capacitor. Again, you have your live and neutral connections. Fits onto the terminals like so, and you can attach a bridge from one of these pins to somewhere to emulate a thermostat. I haven't needed to connect one of these up, so I'm not 100% sure on how to do it, but if you can find a wiring diagram like this one inside the cabinet of a refrigerator or something, it will help you out in a great way. If you don't have a wiring diagram or the right capacitors or the right starting relay with your compressor, you may be in a bit of trouble, because the safest way to do this is to use the factory starting device. Don't try swapping wires around or connecting random capacitors. You'll either destroy the compressor, the capacitor, or simply fry yourself in the process. And I don't need my viewers getting electrocuted. So if you get the chance, select the whole refrigerator from the scrapyard and dismantle it yourself. Make sure it's a modern one, because releasing R22 or R12 to the environment is illegal. However, here in Australia, releasing R134A or R404A is completely legal. So if you get a modern one with 134A, don't be afraid to cut the lines. Larger compressors like this scroll compressor often have it marked around the outside of the terminal block. You have your common, your start, and your run, number 3 down here. That comes up to a starting device. Without that you would not be able to run this compressor, although you could substitute a contactor for it. You have your common lead connected to the neutral block, and you have your start lead connected to your start capacitor up here. Generally the bigger the compressor is, the more current it's going to draw, so bear that in mind when you build or design a vacuum pump using a large scroll or other air conditioning compressor. But they are by far the best kind of pump because they are very efficient and very strong.